Good morning, children. In the previous class, you have studied about Newton's third law of motion and law of conservation of momentum. In today's class, you will study about the problems based on Newton's third law of motion and law of conservation of momentum. Let us know about the formulas which we are using to solve the problems. You know, when two bodies A and B interact with each other, the body A exerts a force on body B. On the other hand, the body B also exerts an equal amount of force on body A but in opposite direction. Here, the force exerted by the body A on B is given by FAB, and the force exerted by the body B on A is represented by FBA. Since these two forces are equal and opposite, we can write it as FAB is equal to minus FBA. Next, according to law of conservation of momentum, total momentum after collision is equal to total momentum before collision. The total momentum after collision is given by m1v1 plus m2v2, and the total momentum before collision is given by m1u1 plus m2u2. Therefore, m1v1 plus m2v2 is equal to m1u1 plus m2u2. Here, m1 and m2 are masses of two bodies. u1 and u2 are their respective velocities before collision, and v1 and v2 are their respective velocities after collision. Next, when the two bodies are at rest, their initial velocities are 0. So when their initial velocities are 0, u1 is equal to 0 and u2 is equal to 0. Therefore, m1v1 plus m2v2 is equal to 0. We can write it as v2 is equal to minus m1v1 by m2. We can apply this formula in case of firing of a bullet from a gun. Here, m1 and m2 are the masses of gun and the bullet, and v1 and v2 are the velocities of the gun and the bullet. Take on the first problem. When two bodies A and B interact with each other, A exerts a force of 10 Newton on B towards east. What is the force exerted by B on A? Here, the force exerted by A on B is FAB, that is given 10 Newton, and you have to find out the force exerted by B on A, that is FBA. FBA is equal to minus of FAB. So the FAB is 10 Newton, therefore FBA is also 10 Newton. Therefore, FBA is equal to minus 10 Newton. Here, the negative sign represents the body B exerts 10 Newton of force on body A towards west. Next question. A bullet of mass 50 gram is fired from a gun of mass 6 kg with a velocity of 400 meter per second. Calculate the recoil velocity of the gun. Here, let the mass of the bullet be m1 and its velocity v1, and the mass of the gun be m2 and its velocity v2. Here, m1 is equal to 50 gram. Convert the gram into kg. 50 gram is equal to 1 by 20 kg. Next, m2 is given 6 kg, and the velocity of the bullet is given 400 meter per second. So v1 is 400 meter per second. Find out the recoil velocity of the gun v2. Here we can use m1 v1 plus m2 v2 is equal to 0. Next we can write V2 is equal to minus m1 v1 by m2. m1 is 1 by 20 and v1 is 400 and m2 is 6 kg. Divide 20 ones are 20, 20 za. Next, divide 20 by 6. 6 ones are 6 3s are 18, 3 again 6 3s are 18. So, V2 is equal to minus 3.3 meter per second. Therefore, the recoil velocity of the gun is minus 3.3 meter per second. Next question. A machine gun fires 25 gram bullets at the rate of 600 bullets per minute with a speed of 200 meter per second. Calculate the force required to keep the gun in position. Here, the mass of the bullet is given 25 gram. Convert 25 gram into kg. To convert the gram into kg, divide 25 by 1000. So, 25 gram is equal to 1 by 40 kg. Next, speed of the bullet is given 200 meter per second. And the number of bullets fired per minute is 600. So, find out the number of bullets fired per second. To find the number of bullets fired per second, divide 600 by 60, you will get 10. Therefore, the number of bullets fired per second is 10. Next, the force required to keep the gun in position is rate of change of momentum of bullets. The rate of change of momentum of bullets is nothing but momentum of bullets fired per second. The momentum of bullets fired per second is equal to m into n into v. M is mass of the bullet, n is number of bullets and v is the speed of the bullet. Now substitute 1 by 40 in place of m and 10 in place of n and 200 in place of v. Divide 41s are 40, 45s are 200 and 10 into 5 is 50. Therefore, the force required is 50 Newton. Therefore, the force required to keep the gun in position is 50 Newton. Next question. A bullet of mass 200 gram moving with a velocity of 300 meter per second gets embedded in a freely suspended wooden block of mass 880 gram. What is the velocity acquired by the block? Here, the mass of the bullet is given. Let the mass of the bullet be m1 and the mass of the wooden block be m2. The mass of the bullet is 20 gram. Convert gram into kg. To convert gram into kg, divide 20 by 1000. So, 20 gram is equal to 1 by 50 kg. And the initial velocity of the bullet is 300 meter per second. And the mass of the wooden block M2 is 880 gram. Convert the gram into kg. 880 gram is equal to 22 by 25 kg. And initially the wooden block is at rest. Therefore, the initial velocity of the wooden block is 0. We have to find out the velocity of the block with bullet embedded in it. Now, apply the law of conservation of momentum. You know, m1 plus m2 into v is equal to m1 u1 plus m2 u2. Now substitute 1 by 50 in place of m1 and 22 by 25 in place of m2, and we have to find out. And m1 is 1 by 50 and u1 is 300 plus m2 is 22 by 25 and u2 is 0. Next, take the LCM for 50 and 25. The LCM is 50. Divide the LCM 50 by the denominator 50. It divides one time. So 1 into 1 is 1. Divide 50 by 25. It divides 2 times. So 2 into 22 is 44. Into V is equal to, divide 300 by 50. It divides 6 times. 0 into 22 by 25 is 0. Next, 45 by 50 V is equal to 6. Next, V is equal to 50 into 6 by 45. 5 nines are 45 and 5 tens are 50. Then 3 twos are 6, 3 threes are 9. Next, V is equal to 20 by 3. V is equal to 20 by 3. Divide 20 by 3. 3 ones are 3 6 are 18, 2 remainder, again 3 6 are 18, again 2 remainder, 3 6 are. So V is equal to 6.66. So we can write it as V is equal to 6.7 meter per second. Therefore, the velocity acquired by the block is 6.7 meter per second. Next question. A girl of mass 50 kg jumps out of a rowing boat of mass 300 kg onto the bank with a horizontal velocity of 3 meter per second. With what velocity does the boat begin to move backwards? Here, let the mass of the girl be m1 and the mass of the boat be m2. m1 is 50 kg and m2 is 300 kg, and the velocity of the girl v1 is 3 meter per second. We have to find out the velocity of the boat. m1 is 50 kg, v1 is 3 meter per second, m2 is 300 kg, and find out v2. By using m1 v1 plus m2 v2 is equal to 0, we can find out v2. m1 v1 plus m2 v2 is equal to 0, therefore v2 is equal to minus m1 v1 by m2. Now substitute 50 in place of m1, 3 in place of v1 and 300 in place of m2. Now simplify. 50 ones are 50, 6 are 300, 3 ones are 3 twos are. So minus 1 by 2 minus 1 by 2 is equal to 0.5 meter per second. Therefore, the boat begins to move backwards with the velocity 0.5 meter per second. Here, the negative sign represents the backward motion of the boat. Next question. A boy of mass 60 kg running at 3 meter per second jumps onto a trolley of mass 140 kg moving with a velocity of 1.5 meter per second in the same direction. What is their common velocity? Let the mass of the boy be 60 kg. Let the mass of the boy be m1 and the mass of the trolley be m2. Here m1 is equal to 60 kg and the initial velocity of the boy is 3 meter per second and the mass of the trolley M2 is equal to 140 kg and its initial velocity U2 is 1.5 meter per second, then we have to find out the common velocity V. Now we can apply the law of conservation of momentum. It is given by m1 plus m2 into v is equal to m1 u1 plus m2 u2. Now substitute 60 in place of m1 and 140 in place of m2, and v we have to find out. And m1 is equal to 60 and u1 is 30 and m2 is 140 and u2 is 1.5. Next, 60 plus 140 is equal to 200v. 63 is 180 plus 140 into 1.5 is 210. Next, 200v is equal to 180 plus 210 is 390. So 200v is equal to 390. Then v is equal to 390 by 200. Then divide 390 and 200 by 2. You will get 195 by 100. 195 by 100 is equal to 1.95 meter per second. Therefore, their common velocity is 1.95 meter per second. Next question. A girl of mass 40 kg jumps with a horizontal velocity of 5 meter per second onto a stationary cart with frictionless wheels. The mass of the cart is 3 kg. What is her velocity as the cart starts moving? Assume that there is no external unbalanced force working in the horizontal direction. Here, let us consider the mass of the girl be m1 and the mass of the cart be m2, and their initial velocities be u1 and u2. And let the velocity of the girl as the cart starts moving be v. m1 is 40 kg and u1 is 5 meter per second. m2 is 3 kg, and since the cart is initially stationary, its initial velocity is 0. We have to find out the velocity of the girl v as the cart starts moving. Now apply the law of conservation of momentum. By the law of conservation of momentum, you know m1 plus m2 into v is equal to m1 u1 plus m2 u2. Now substitute 40 in place of m1 and 3 in place of m2, and v we have to find out. And next, m1 is 40 and u1 is 5, m2 is 3 and u2 is 0. Next, 40 plus 3 is equal to 43v. 45 is 200 plus 3 into 0 is 0. So 43v is equal to 200 and v is equal to 200 by 43. Divide 200 by 43, it divides 4.65 times. Therefore, v is equal to 4.65 meter per second. Therefore, the velocity of the girl as the cart starts moving is 4.65 meter per second.